Okay, so this is problem 27 of chapter 9 of Giancoli 6th edition. This problem is very similar to the one we solved in class. The difference now is just that we have a person on top of the ladder. Okay, so we have, let's try to draw this here. We have this ladder hanging around against a wall. Okay? And here we have the ground. This wall is frictionless, okay, but not the ground. Okay, the ground has friction. Okay, this ladder touching the ground has two forces. One is the normal force that we are going to call FGY from ground in the Y direction, and the other one is this FGX, which is the friction force. Okay, it's what prevents the ladder from sliding down. What else do we have? We have the ladder is touching the wall, so we have a force, a normal force caused by this wall, okay? Always perpendicular to the surface. We also have the weight of this ladder, and this weight we are going to put here. So mg is the weight of the ladder. So this whole distance here is given to us, 3 meters. So I know that the distance from the weight of the ladder is 1.5, okay? Because it's right on the middle. What else do we have? We have that person, and this person is here, okay? And they tell us we have the weight of this person, so we have here the weight of this person. And we also know where this person is. They say that the ladder begins to slip at its base when this painter's feet are 70% of the way up the length of the ladder. That is, this height here is 70% of the height of the point where the ladder is touching. So this whole height here is 4 meters. From that we know that this part here is 70%, so this part is 2.8. Okay? And we also know that this distance here is 2.1, 70% of 3 meters. So all this is given in the drawing. Okay? What we want to know is what is the coefficient of static friction. So let's put here, what is the coefficient of static friction between the ladder and the floor and the ground. Okay, how are we going to solve that? Well, let's first think about what is this coefficient of static friction. As I said, the FGX, okay, is the friction force. All right, and we know that the friction force is the coefficient that we are after multiplied by the normal force. And what is the normal force? The FGY. Okay? So what we need to compute to find this coefficient, well, we need these two forces. Okay, so let's write now all the equations for the forces in the x direction, the forces in the y direction, and torque. So let me start with the forces in the x direction. What do we have in the x direction? Well, just the FGX and the force of the wall equals to 0. So I'm using here this reference frame. Okay, so from here I see that the FGX is just the force from the wall. So that coefficient that we want to obtain is equal to the force from the wall that I do not have and the FGY that I do not have. So this is how we are going to find this coefficient. Okay, let's now write the equations in the y direction. What do we get in the y direction? Well, we just have the FGY minus the weight of the ladder minus the weight of the person equals to 0. Okay, so good. From here, I find the FGY, so one step of the problem is solved. Now we need to find the force from the wall, the normal force by touching the wall. And for that, we are going to use torque. That's the only equation left. that we haven't used yet. So what do we have for torque? Okay, let's choose an axis of rotation, and a very convenient one is to put it right here so we don't need to worry about two forces. Okay, all right, then what do we have? The weight, the two weights trying to move this ladder clockwise. So I have minus mg, the weight of the ladder, and the position where it is 1.5. Well, let's think a little bit, what is this 1.5? You see that this 1.5 is the lever arm. Okay, what is the lever arm? It's the distance from the axis of rotation to the direction of mg. So this 1.5 meters here is the lever arm for the weight of the ladder. So I'm going to put it here. Okay, let me go now for the weight of the person. Again, trying to move this ladder clockwise, so it's negative. And what is the lever arm for this person? Well, again, the lever arm is the distance from the center, from the axis of rotation, to the line, the perpendicular distance from the axis of rotation to the line of the force. Okay, so this is now, this lever arm is 2.1. So I'm going to put here 2.1. What else do we have? Well, the force from the wall. This one is trying to move the ladder clockwise, so positive. And what is the lever arm? Okay, so I'm going to draw the direction, a line for the direction of this force. Here it is. And I want the perpendicular distance from the axis of rotation to the line of that force. And this is 4. This is 0. So from this equation we are going to get the force from the wall. And now we are done. We can find the coefficient.